Welcome to another edition of Brain Maths. On today's edition, we want to look at fraction. But before we start working on fraction, we need to know what fraction is all about. If you are given an orange, this is one whole orange. But if this orange is to be shared between more than two people, or let's say two people, for instance, we are going to need to divide this orange into two. So, since the orange is divided into two, we say one person is going to take one part of the two division. So, this person that is taking this one is taking one out of two, and the other person is also taking one out of two. So if this half is combined together, it becomes 1. But when a 1 is divided into more than a part, then we call it a fraction. If this orange is divided again, we have 4 different parts, and each of the parts is regarded as one part out of 4. So we can have fraction in different type of things. Fraction may be gotten from anything. Let's look at this brick. If we divide this one brick into several parts, how many parts do we have here? 1, 2, 3, 4, 5, 6. Each of these is regarded as 1 over 6. Each part is regarded as 1 out of 6. So this is simple example of what a fraction is. Now let's look at different types of fractions that we have. The first and the most common type of fraction is referred to as proper fraction. A fraction is regarded as a proper fraction when the numerator is smaller to the denominator. That is, when the load that is being carried by the denominator is smaller to the denominator itself. So 1 over 2 is a good example of a proper fraction. Another example may be 5 over 7. So whatever you have, whenever you are given a fraction that has a smaller denominator, a smaller numerator rather, compared to the denominator, that fraction is referred to as proper fraction. Then we have improper fraction. Improper fraction is a fraction where the numerator is bigger than the denominator. If you look at this, you will see that the number at the top is bigger than the one at the bottom. That is to say that the denominator is carrying a load that is heavier than itself. Another one may be 11 over 5. Now from improper fraction, we get another type of fraction that is referred to as mixed fraction. Mixed fraction. If you look at this improper fraction, you will see that we can get 3 in 2 different places from 8. How many 3 can we get in 8? We'll say 2. But we still have a remainder, and the remainder is 2 over 3. So what I have written here, this type of fraction is called mixed fraction. Let's look at 11 over 5. How many 5 can we get in 11? 2. Remainder 1 over 5. Now let's try to reduce this fractions to their lowest terms. What it means to reduce a fraction to its lowest term is that you have to divide all these fractions by common numbers that is possible to divide them until there is no number to be divided again. If you look at 12 and 36, for instance, if you look at 12 and 36, you know that 2 will divide 12 and 2 will divide 36. So how many of 2 can we get in 12? That is 6 over how many 2 can we get in 36? In 3 we get 1, remainder 1. In 16 we get 8. If you look again, we see that 6 and 18 can still be divided by 2, 3, and then 6 itself. So if you don't want to waste your time, you can decide to divide both of them by 6 at once, or you still take your time to enjoy the mathematics. So let's try to divide by 6. How many 6 can we get in 6? 1. And how many 6 can we get in 18? That is 3. Coming to question B, we have to divide 105 by 147. So we need to test which number will divide the two of them to know what we are going to use to divide them. Let's start with 3. If you test 3 with 105, we say how many 3 in 10? That is 3, remainder 1. If you put the 1 here, it becomes 15. How many 3 can we get in 15? That is 5. Then come to 147. How many 3 can we get in 14? That is what? 4. Remainder 2. How many 3 can we get in 27? That is also possible. Then let's try another number like 7, because if you look at the denominator, it is obvious that we have 14 and 7, which means if 14 divide 7, rather 14 divide by 7, that will give us 2, and 7 divided by 7, that will give us 1. So let's test the numerator. How many 7 can we get in 10? 1. Remainder 3. That means we are going to have 35, which 7 will also divide conveniently. So let's take the bigger number. How many 7 can we get in 10? 1. Remainder 3. How many 7 can we get in 35? That is 5. Divided by how many 7 can we get in 14? 2. And how many 7 can we get in 7? 1. It is still possible to divide this further by 3. How many 3 can we get in 15? That is 5. Remainder, no remainder. How many 3 can we get in 21? 7. So looking at this, we have gotten to its lowest term, because if you look at the first one, it looks like a proper fraction, and the second one also looks like a proper fraction. So let's go to the third one. The third one is 225 divided by 625. Without wasting our time, it is obvious from their last figures that 5 will divide the two of them conveniently. So how many 5 can we get in 22? That is 4. Remainder 2. How many 5 can we get in 25? That will give us 5. Then in 625, start with the first number. How many 5 can we get in 6? 1. Remainder 1. How many 5 can we get in 12? 2. Remainder 2. And how many 5 can we get in 25? We say 5. Still on the division, 5 can still divide 45 and 125. How many 5 can we get in 45? That gives 9. How many 5 can we get in 12? 2. Remainder 2. How many 5 can we get in 25? That will give us 5. So if you look at the last one here, which is 9 over 25, I'm sure we all know that no number can divide both 9 and 25. So on this note, we say 9 over 25 is the lowest and the simplest term that we can reduce 225 by 625. All right, let's move to addition and subtraction of fractions. Now, under addition of fraction, there are a series of ways we solve problem in addition of fractions. The first one is when the denominators are the same. When you are given a fraction with the same denominators, you don't have to stress yourself. Just look at the numerators, add all of them together. 1 plus 4 is what? 5 over, we have the same denominators, so our answer will be 5 over 3. But when the denominators are not the same, like we are given in the second question, you see that we have 1 over 5 plus 7 over 10. Then the next thing we'll do is to find the LCM. And finding the LCM simply means we want to look for a number that we can get 5 from it, we can also get 10 from it. So the possible way we test our LCM is to first look at the two numbers given to us. Is one of them a product of the second one or a multiple of the second one? 5 is one of the multiples of 10. 5 times 2 will give us 10. And 10 itself is another multiple of 10. 10 times 1 will give us 10. So it is easy for us to say 10 is the LCM of 5 and 10. But if you are doubting what you have, you can decide to test the LCM by yourself by writing out the two numbers, then decide which number will divide the two of them conveniently. Let's take 5 as the first divisor. How many 5 can we get in 5? 1. 5 in 10, 2. Then we take 2 again because 2 will divide 2. So 1, 2 in 2, 1. 5 times 2 will give us 10. So the LCM of 5 and 10 is 10. So how many 5 can we get in this 10? That will give us 2. Multiply the 2 by the numerator. We have 2 plus how many 10 can we get in 10? That is 1, and 1 times 7 will give us 7. So we say 2 plus 7, 9 over 10. The third question is where we have the denominators where we cannot say one is a multiple of the other one. So in this case, we multiply both denominators to get our LCM, or still use the method of finding the LCM that I showed earlier. So 2 times 5 will give us 10. How many 2 can we get in 10? 5. 5 times 1, which is the numerator here, will give us 5, plus how many 5 can we get in 10? That is 2, and 2 times 3 will give us 6. So we say 5 plus 6, 11 over 10. But what we are having here is an improper fraction because the numerator is bigger than the denominator. So in that case, we take our fraction to a mixed fraction or mixed numbers. How many 10 can we get in 11? 1. Remainder 1 over 10. Now let's come to the other side where we have subtraction. The same rule that we use on the addition side is what we will try to apply in the subtraction part as well. When you are given subtraction of fractions with the same denominators, it is quite easy to solve. All you need to do is just to take one of the denominators and then subtract the numerators from each other, and that will give us 3 over 7. So Let's come to the second one. If you look at what we have in the second one, we have 4, we also have 2, and 2 is a multiple of 4. 4 is also a multiple of itself. So in this case, we say our LCM for 4 and 2 is 4. How many 4 can we get in 4? 1. 1 times 3, 3 minus how many 2 can we get in 4? 2. 2 times 1, 2. 3 minus 2 will give us 1 over 4. The last question on this slide, we have the denominators that are not multiples of one another. So in that case, we find the LCM by multiplying the two numbers by themselves. So 8 times 10 will give us 80 as our LCM. How many 8 can we get in 80? That is 10. 10 times 7 will give us 70. Minus how many 10 can we get in 80? That is 8. 8 times 7, that is giving us 56. 56 taken from 70 will give us 14 over 80. So looking at 14 and 80, it is possible for us to divide the two of them by 2. How many 2 can we get in 14? That is 7. And how many 2 can we get in 80? That is 40. So 7 cannot cut 40, and the 2 are already giving us a kind of proper fraction. Here, we want to look at a possible way to solve addition and subtraction of fraction all in one question. Looking at question number 1, we have 3 odd number 1 over 4 minus 1, 1 over 2 plus 2, 1 over 3. The first thing we are expected to do here is to take these fractions back to their improper form. So we say 3 times 4 will give us 12. 12 plus 1, we have 13 over 4 minus 2 times 1, 2 plus 1, 3 over 2 plus 3 times 2, 6 plus 1, 7 over 3. Having taken them to their improper form, the next is to find their LCM. We want to find the LCM of 4, 2, and 3. If it is possible for us to get one out of the 3 that is big enough to be the multiples of the other one, that is, can 2 go in 4 or 3 go in 4? Since that is not possible, then we find their LCM by using the method I showed in the previous lesson. So the first number we will use here is 2. How many 2 can we get in 4? 2. 2 in 2, 1. It's not possible to divide 3. We repeat 3. So we can still use 2 again. 2 in 2, 1. 1. We repeat 3. Then we can divide 3 by 3 now. So we multiply all this together by saying 2 times 2, 4, and 4 times 3, 12. So their LCM is 12. Now, how many 4 can we get in 12? That is 3. 3 times 13 will give us 39. Minus, how many 2 can we get in 12? That is 6. 6 times 3, that is 18. Plus, how many 3 can we get in 12? 4. 4 times 7, 28. So we need to add and subtract all these numbers. So we have 39 minus 18. That is going to give us 21, and 21 plus 28, that will give us 49 divided by 12. So can we possibly divide this by any number? It is not possible. But can we get 12 in 49? Yes. How many 12 can we get in 49? That is 4. 12 times 4 will give us 48. Remainder 1 over 12. Then the second question. The first thing we are going to do here also is to take each one of them to their improper form. 6 times 5 will give us 30. 30 plus 1 will be 31 over 5 minus 3 times 2, 6. 6 plus 2, 8 over 3 plus 6 times 1, 6 plus 1, 7 over 6. So the next is to find the LCM of these three numbers. The LCM is gotten this way. We start by using 2. 2 cannot divide this 2, but it will divide 6. So we get 3 from that. So we can use 3 now. 3 cannot divide 5, but can divide these 3's. Then we use 5 now. 5 will give us 1 or 2. So 2 times 3 is 6, and 6 times 5 will give us 30. So their LCM is 30. How many 5 can we get in 30? That is 6. 6 times 31. That is going to give us 186. Check it out by yourself. 6 times 1, 6. 6 times 3, 18. So that is 186. How many 3 can we get in 30? That is 10. 10 times 8 will give us 80. Plus, how many 6 can we get in 30? That is 5. 5 times 7 will give us 35. So now we add the numbers and subtract. So we have 186 minus 80. That will give us 106. And 106 plus 35. We are going to have 141 over 30. No single number will divide 30 and 141. But 30 can go in 141 in 4 different places. That is going to give us 120. 30 times 4, 120. If you take 120 from 141, you'll be left with 21 over 30. So this is our answer for this question. I am going to leave you with these 2 questions as practice questions. Try to solve the questions and leave your answers in the comment section. Before our meeting in the next video, try to subscribe if you have not done so, and turn on your notification. Until I meet you again, do have a wonderful day.